Hi everyone, my name is Ramandeep Singh and today I'm going to present the second paper assigned to me, and the title of the paper is Non-Fungible Token NFT Overview, Evaluation, Opportunities and Challenges. So let's get started. First of all, what is NFT? NFT stands for Non-Fungible Token. It is a type of cryptocurrency that is derived by the smart contracts of Ethereum. NFT differs from the classical cryptocurrencies such as Bitcoin in their intrinsic features. Bitcoin is a standard coin in which all the coins are equivalent and indistinguishable. In contrast, NFT is unique, which cannot be exchanged like Bitcoin. It cannot be exchanged like for like, making it suitable for identifying something or someone in a unique way. To be specific, by using NFTs on smart contracts, a creator can easily prove the existence and ownership of digital assets in the form of videos, images, arts, event tickets, etc. So it's basically a kind of unit of data stored on a blockchain that can be sold and traded. Moving forward, this paper discussed the following about the NFT. First of all, this paper discussed the design model of the NFT. Specifically, they identify the technical components that are used to construct NFTs, and then they present their protocols, standards, and targeted properties. Second emphasis is on security evaluation. They adopt the stride threat and risk evaluation to investigate the potential security issues. Based on that, they also discuss the corresponding defense measures for the issue. And the third one is the future opportunities of the NFTs. Applying NFTs to real scenarios will boost a wide range of new applications. So they give a set of practical instances leveraging NFTs with a great success or prosperous markets. And finally, the last thing would be the open challenges in the NFT ecosystem. Blockchain based NFT system will confront unavoidable problems like privacy issues, data inaccessibility, etc. So they outline all the open challenges existing in the state of art NFT solutions. So moving forward, first of all, I will cover the technical components. The technical components, these are the basic fundamental components for building the NFT. So first one is the blockchain. So blockchain, as we all know, blockchain is defined as a distributed and attached only database that maintains a list of data records linked and protected using cryptographic protocols. So in this each block, so it's like a kind of representation, like if we can assume it like a block. Here each block contains a cryptographic hash of previous block. Hash is something they hash is something like equivalent. They give some specific value to one block, and it's kind of linked list in the data structures. In linked list, we capture we have a pointer that points to the next node of the element, and here we have a block that contains the address of the previous block. So it's like kind of, that's why its name is blockchain. It's kind of a chain of blocks. And so blockchain provides a solution to the once the shared data on the blockchain is confirmed in most distributed nodes, it becomes immutable because any change in the stored data will invalidate all subsequent data, as we know. Because so we once any data is stored on a blockchain, it cannot be changed because the data is already linked. We have a number of blocks linked. So if we change one block, that further data we cannot validate the further data. So the most prevailing blockchain pattern used in NFT is Ethereum. So we use most of the NFTs are built on the Ethereum. So moving forward, coming to the smart contract. Smart contracts, they are basically programs stored on a blockchain that run when predetermined conditions are met. And they smart contracts actually were originally introduced aiming to accelerate, verify, or execute digital negotiation. Then Ethereum further developed smart contracts in the blockchain system. Smart contracts enable unfamiliar and decentralized participants to conduct fair exchanges without trusted third party, and further propose a unified method to build applications across a wide range of industries. So it's just like it's approached. So we don't before this, for to make a contract there are like three parties. So it's just elimination of the third party. And then most of NFT solutions rely on smart contracts based blockchain platforms to ensure their order sensitive executions. And so moving forward, we come across address and transactions. So blockchain address and transactions are the essential concepts in cryptocurrencies. A blockchain address is a unique identifier for a user to send and receive the assets, which is like kind of similar to the bank account. It consists of a fixed number of alphanumeric characters. They generated from a pair of a public and a private key. So, like if I want to transfer NFT to somebody, so to transfer NFT, the owner must prove in possession of the corresponding private key and send the asset to another address with the corresponding digital signature. So, these operations are usually performed with the help of cryptographic wallet and is represented as sending a transaction to involve smart contracts. And then moving forward, there is a data encoding. So encoding is just a process of converting data from one form to the another. Normally, when like we say that normally many files are often encoded into either efficient compressed format for saving disk space or into uncompressed format for high quality and resolution. So in the mainstream blockchain systems such as Bitcoin and Ethereum, they employ hex values to encode the transaction elements such as the function names, parameters, and return values. This implies that the raw NFT data must follow these rules. So that was about the technical components that I used to make the NFT. So come moving forward, I will cover the protocols, standards, and the properties. So basically, there are two protocols. One is top to bottom, and another approach is bottom to top. So the top to bottom is building NFT from the initiator and then sell them to the buyer, and the bottom to top is sending an NFT template, setting an NFT template, and every user can create their unique on top NFTs. So first of all, I will cover the top to bottom and then bottom to top. So in top to bottom, there are two roles involved. One is NFT owner, another is NFT buyer. NFT owner is the person who owns NFT, and NFT buyer is the who wants to buy the NFT. So the transaction will be between these two entities. So following, like there are some steps involved in this protocol top to bottom. So I will discuss one by one all of them. So first one is NFT digitize. The NFT owner checks that the file title description are completely accurate. And then if once he or she is satisfied, then he or she digitize the raw data into proper format. And then the second thing is NFT store. An NFT owner stores the raw data into an external database outside the blockchain. Though we can also store in a blockchain, but that will be gas consuming. So basically, they store the raw data outside in external databases. And then there is NFT sign. The third step is NFT sign. The NFT owner signs a transaction including the hash of NFT data and then sends the transaction to the smart contract. And the fourth step is NFT mint and trade. After the smart contract receives the transaction with the NFT data, the minting and the trading process begins. The main mechanism behind the NFT is the logic of the token standards. And then NFT confirm. The next step is the NFT confirm. Once the transaction is confirmed, the minting process gets completed. By this approach, NFT will forever link to a unique blockchain address as their persistence evidence. So this is how NFT are like uploaded and NFTs are minted. So moving forward to the next protocol, that is bottom to top. Following two roles are involved in the bottom to top. First one is the NFT creator and the second one is the NFT buyer. So there are a few steps that are involved in this approach. The first one is template create. The project founder initiates a template via the smart contract to set up several basic rules such as different features, such a different feature like you can let's take an example of game. So different in the game, the different feature can be like style, weapons, or accessories. And the second step is NFT randomize. So once a buyer bids for an NFT, he or she can customize the NFT product with a set of additional features on the top of the basic lines. So these additional features will be randomly selected, but they have to be defined during the initiation, like during the template create step, they have to be defined. So you can only use the predefined features to randomize your NFT. And once you are done with this, then the third step would be NFT mint and trade. Minting and trading process starts when the corresponding smart contract is triggered. It's same, like it's these steps are similar to the previous approach, only the first two steps are different. And then the NFT confirm the all the procedures in NFT. So once all procedures are conducted through smart contracts, then there is a confirmation. So the generated NFT will be persistently stored on chain when consensus procedures has been completed. So this one was the protocols. Now moving forward, I will cover the token standards. I would also like to mention one thing here. So whenever an NFT is minted or sold, a new transaction is required to send to invoke the smart contract we created for an NFT. So after the transaction is confirmed, the NFT metadata and ownership details are added back to new block. So at the end of the day, because we are adding data to the blockchain, so for every transaction, every minted or so every mint or sold transaction, data will be added to the blockchain in a new block. So, and now moving forward, token standards. So basically, there are three types of token standards: ERC20, ERC721, and ERC1155. And the most prevailing token standards come from the ERC20 is for fungible tokens. It introduced the concept of fungible tokens that can be issued on the top of Ethereum once satisfying the requirements that I mentioned in the smart contracts. And the standard makes tokens the same as another one in terms of both the type and values. So basically they are indistinguishable from each other. That's why the word fungible. And so it means that any arbitrary token is equal to all other tokens. So, and but in contrast to that, ERC 721 introduced a non-fungible token standard that differ from the fungible tokens. So this type of token is unique, that can be distinguished from another token. That's our case in NFT. So we want our NFT to be unique. So in this case, so NFTs are basically based on this standard or the ERC 1155. And so every NFT has a unit 256 variable called token ID, and the pair of contract address and the unit 256 token ID is globally unique. So that's the uniqueness property of the NFT. And then the another standard is ERC 1155. So basically it extends the representation of both fungible and non-fungible tokens. It provides an interface that can represent any number of tokens. In previous standards, like every token ID in contact can only contain a single type of token, but in this case, so it can contain multiple tokens. So basically these are kind of interfaces, so they have some functions. So if you want to create a contract, you can just, it's just like if you see in Java, if we have an interface and we need to create a class on top of it, we just implement that interface. So basically to create your contract, you need to implement these interfaces. Either you can go with 721 or ERC1155. So they have predefined functions, and by implementation I means you need to define that function. You need to provide the definitions of that functions. So that's all, that's about the token standards. So coming about the properties of the NFT, like the properties that are desired. So first one is verifiability. So NFT with its token metadata and its ownership can be publicly verified. And the second one is transparent execution. So activities like minting, selling, and purchasing are publicly accessible. And the third one is availability. So it means the system should never go down. All the tokens and the issued NFT is always available to buy and sell. And the fourth one is tamper resistance. The NFT metadata and its trading records cannot be manipulated once the transactions are deemed as confirmed. And the fifth one is atomicity. Trading NFT can be completed in one atomic consistent, isolated, and durable. That's ACID transaction. The NFT can run in the same shared execution state. And the sixth one is tradability. Like every NFT and its corresponding products can be arbitrarily traded and exchanged. So that was about the protocols, properties, and standards. So coming to the moving forward to the next section, that is a security evaluation. So they adopted the stride threat and risk evaluation, which covers all the security aspects of a system. So that the aspects like the aspects are authenticity, integrity, non-reputability, availability, and access control. So first, so stride. So basically, so I will tell you one by one. So the stride, S in stride stands for spoofing. So spoofing is ability to impersonate another entity, for example another person or a computer, on a system which corresponds to authenticity. So when a user interacts or to mint or sell NFT, a malicious user can exploit authentication vulnerabilities to steal the user's private key to transfer the ownership of NFT illegally. So it's recommended having a formal verification for the NFT smart contract and to use the cold wallet to prevent private key leakage. And the T in stride stand for tampering. So tampering refers to the malicious modification of NFT data which violates the integrity. So the metadata and the ownership of, and so we know that the metadata and ownership of NFTs cannot be maliciously modified after the transaction is confirmed, because they are in blockchain, and once the data is stored in the blockchain, we cannot change it. However, the data stored outside the blockchain may be manipulated. So we know that we store raw data outside the blockchain that can be modified. So to overcome this, so it is recommended that users recommended to user to send both the hash data as well as original data to the NFT buyer when trading, exchanging NFT related properties. And the R stands for reputation, and it refers to the situation where the author of a statement cannot dispute, like which is related to the security property of non-reputability. So the fact that a user sends NFT to another user cannot deny, because that's in a blockchain and it's granted by the security of the blockchain, and because anything that goes to the blockchain, it cannot be modified. So they cannot deny. However, the hash data that may be tampered by the malicious attacker, or a hash data that may bind with an attacker's address, so there can be a problem. So to overcome this, using a multi-signature contract can partly solve this issue, since each binding must be confirmed by more than one participant. And the fourth one is information disclosure. So when the information is exposed to, it's basically, it refers to when the information exposed to unauthorized users, which violates confidentiality. And so in the NFT system, the state information and the instruction code in the smart contracts are entirely transparent, and any state and its changes are publicly accessible to any observer. So it's recommended to the NFT developer to use privacy preserving smart contracts instead of plain smart contracts to protect users' privacy. So next one is the D in stride stand from denial of service. So it's kind of a network attack malicious user in which a malicious attacker aims to render a server unavailable to its intended users by interrupting the normal function. So DOS violates the availability denial of service. It's called a DOS. So DOS violates the availability and breaks down the NFT service, which can indeed be used by unauthorized user. So that's about the denial of service. And moving forward is elevation of privilege. So elevation of privilege is a property that is related to the authorization. In this type of threat, an attacker may gain permissions beyond those initially granted. So these are the six fundamental stride evaluation. So this is the summary of everything. So first one is the spoofing. So the security issue is that an attacker may exploit authentication vulnerabilities, or attacker may steal a user's private key. So the solution for that is a formal verification of the smart contract, or using the cold wallet to prevent the private key leakage. The second one is the tampering. So the issue in this is that data stored outside the blockchain may be manipulated. So solution for that is like, it's a recommended solution. So it doesn't provide 100% guarantee, but like it's feasible. So the solution is sending both the original data and hash data to the NFT buyer when trading NFTs. And the third one is reputation. So the issue is the hash data may bind with an attacker's address. So using a multi-signature contract partly can solve this problem. Information disclosure: the attacker can easily exploit the hash and transaction to link a particular NFT buyer or seller. So the solution for that is using a privacy preserving smart contracts instead of smart contracts to protect users' privacy. And the next comes denial of service. The NFT data may become unavailable if the asset is stored outside the blockchain. By using the hybrid blockchain architecture with the weak consensus algorithm, that's the solution for that. And the elevation of privilege: the problem is a poorly designed smart contract may make NFT lose such properties, and the solution is formal verification on the smart contracts. And moving forward to the next section, there's the opportunities. So first one is the boosting gaming industries. So NFT has a great potential in gaming industries. There already exist some crypto games like Crypto Kitties, Crypto Cats, and Crypto Punks, etc. A fascinating feature of such game is the breeding mechanism. So users can personally raise pets and spend so much time breeding new offspring. Then they can also purchase the limited rare edition virtual pets and then sell them at a high price. And the another exciting feature function of the NFT are that it provides ownership records of items in the games and promotes economic marketplace in the ecosystem, benefiting both developer and the buyers and the players. So buyer would be, so player the one who involved in these games will be players. And then the second one is flourishing virtual events. That's a kind of goodbye to traditional online events that rely on centralized companies. So here example is NFT based NFT based tickets. So we know that when buying a ticket in a traditional event ticket market, consumer must trust a third party. Therefore, there is a risk of buying fraud or invalid tickets. So same, and also the same ticket may be sold many times or obtained by extracting from ticket. And so the solution is NFT based ticket. So NFT based ticket represents a ticket issued by the blockchain to demonstrate entitlement to access to any event such as cultural or sport. And an NFT based ticket is unique and scarce, meaning that the ticket holder cannot resell the ticket after it's sold. So that's a very good thing. Like, we can use NFT in a lot of ways. And the third one is protecting digital collectibles. So basically it provides artists a great platform. Artists can sell their art and get a huge amount in return, which was not possible earlier. So earlier we know that to sell their art, they have to handle it to the third party, to a contractor or someone, and then they have to pay them commission. And so that is not now the case. They can make their art and create an NFT of it, and they can sell, and they can get amount in return, which was not possible earlier. So we know that NFTs are selling at $1 million cost, so that was not possible earlier. So, and the artist can, so the one feature of the NFT is that they can receive royalties for future sale. That was not a case in previous. So previously, once they sold NFT, so it's gone. Once they sold their art, then that's okay. So for future sales, they do not get anything. But now they can earn royalties for the future sales as well. So moving forward to the challenges, so there are still some challenges in the NFT. So the first one is the slow confirmation. NFT, so currently NFT system are closely coupled with their underlying blockchain platforms, which make them suffer from low performance. So this results in extremely slow confirmation of NFTs. And the second one is high gas price. So high gas price have become a major problem for NFT marketplace, especially when minting the NFTs at a large scale that requires uploading the metadata to the blockchain network. So every NFT related, so it's expensive because like every NFT related transitions, every, so it is expensive because for any transaction there is a lot of computational resources and storage to be processed. So that's why every NFT related transaction are more expensive than a simple transfer transactions. So to complete a simple NFT trade, to complete can run between US dollar 60 and US 60 to 100 US dollar for each transaction. So expensive fees caused by complex operation and high congestion greatly limit its wide adoption. So that's kind of limitation, huge limitation for the NFT. And the third one is the anonymity and privacy. So most NFT transactions rely on their underlying Ethereum platform, which only provides pseudo anonymity rather than strict anonymity or privacy. So users can partially hide their identities if the link between their real identities and corresponding address are unknown by the public. And so yes, so moving forward, there are also legal pitfalls. So NFT confronts legal and policy issues across a wide range of areas. So potentially concerned areas cover like commodities, cross-border transactions, KYC, etc. And so it is important important to understand the related regulatory and important to know about the regulations before moving into the NFT tracks. So in some countries like such as India and China, the legal situation is strict for cryptocurrencies and also for the NFT sales. So the last one would be the NFT interoperability. So existing NFT ecosystem are isolated from each other. So users once have selected one type of product can only sell by trade them within the same ecosystem network. So that's a huge problem. But so to overcome this, this is because of the blockchain underlying blockchain platform. So but fortunately, most of the NFT related projects adopt Ethereum as their underlying platform. So this indicates that they share a similar data structure and can exchange under the same rules. So it is a limitation, but like fortunately most of the NFTs are based on Ethereum, so it's not of much importance. So the conclusion is like NFT is emerging technology prevailing in the blockchain market. NFT can reshape the market of digital assets because of its properties like uniqueness, ownership, and liquidity. So, thank you.